Here's a GRE word problem. Let's take a look. A van is traveling east on a road at a constant rate of 70 miles an hour. 60 miles to the west, a motorcycle begins heading in the same direction as the van at a constant speed. After 3 hours, the motorcycle has caught up, and the two vehicles are in the same position. What was the speed of the motorcycle? All right, let's draw this out. Always helpful to draw things out so we have an idea of what we're looking at. So we'll put the van right about here. Right, there's the van. And the van is traveling east at a rate, a constant rate, of 70 miles per hour. 70 mph. Okay. And then meanwhile, 60 miles west, so I'll mark that here, there's 60. 60 miles west, you have a motorcyclist, and the motorcyclist is traveling east in the same direction as the van at some unknown speed. So the question is, the motorcyclist catches the van after 3 hours. We want to know how fast the motorcyclist is going. This is a chase problem, right? It's a problem where one vehicle is chasing the other in the same direction. It's not, just to contrast it, it's not a colliding trains problem. We all know those, right? One train is going east, one train is going west, and how long does it take for them to meet in the middle? Not that type of question. On this type of problem, what we're looking at is the gap in the speed. And let me explain that. Let's just pretend, just for the sake of a demonstration, that the motorcyclist was going 80 miles an hour, right? Let's just say, okay, the motorcyclist is traveling east at 80 miles an hour. Let's run this game for 1 hour. What happens? Well, in that 1 hour, the motorcyclist has traveled 80 miles and the van has traveled 70 miles. Everybody follow me on that? Right? So in 1 hour, if the motorcyclist is going 80 miles an hour, the motorcyclist will go 80 miles. And in 1 hour, the van will go 70 miles. Well, the motorcyclist has closed the gap by 10 miles. So even though they start 60 miles apart, after 1 hour, they'll be 50 miles apart. And then another hour, they'll be 40 miles apart. And then another 30, 20, etc. So it'll take 6 hours going 80 miles an hour for the motorcyclist to catch up. So it's clearly not 80 miles an hour, right? Because we're looking for a speed that closes the gap in 3 hours. So 80 is out. Now, we could do this for every one of these and find the one that works. Maybe you already see it. But instead, let's do this a little more, algebraically. It's going to take 3 hours to close the gap. How big is the gap? Well, the gap, according to the problem, is 60 miles. So if we're taking 3 hours to close 60 miles, how far does the gap close every hour? It closes by 20 every hour. 20 times 3 is 60. So if this gap closes by 20 miles an hour, it means that the motorcyclist is going 20 miles an hour faster than the van, right? So if the van's going 70 miles an hour, the motorcyclist is going 90 miles an hour, which makes the correct answer C. For more GRE tips and tricks or to sign up for my online course, follow the link on my profile.